The objective of this assignment is to model the Gemsbok's decay population in Namibia. And by using differential equations, this assignment aims to predict both past and future population, and we use the available data between 2002 and 2017. And why we choose the Gemsbok for the assignment? We choose the Gemsbok because of its population fluctuations due to environmental changes. And about the Gemsbok, the Gemsbok is known as Oryx gazella and is a species of a large antelope native to the arid regions of southern Africa, and they are known for their resilience in harsh desert environments.
Thank you, Mr. for his wonderful introduction regarding the introduction of the Gemsbok population. Now, we will analyze the decline of the Gemsbok population using the differential equation. Let's dive into the data and the math behind this trend. Right, here's the population data from the 2002 to 2017. Notice the fluctuation. Peaks like the 4,808 in 2012 and drops like a 1,197 in 2014. That's quite a lot. And now, our goal is to model this decline to predict future and the past trends. Alright, without further ado, let's get into the solution. First, let's assume that the population follows the exponential decay, which is dp over dt equals to kp. And now we use the separable method in the differential equation, and solving this, we get a p equals to a exponential power of k times t. And where the A is the initial population and K is the decay rate. Now, we need to find the A and K, so we will assume that 2012, which is the peak of the population, is going to be our base of 0, t equals to 0. So when we get a t equals to 0, the exponential will automatically turn into 1, and we get the initial population, which is A equals to 4,808. And now let's level up the t equals to 1. Where the t equals to 1, we can find the k by transfer the algebraic method, and in the end we get the k around negative 0.4021.
Okay, hi everyone. So today I will explain how we use a mathematical model to predict both future and past value using the exponential equation that we got from the previous slide, which is pt equals to 4,808 exponent power of negative 0.4021t. So first we set 2012 as our starting year. So t equals to 0. So for the future value, to find the value in 2015, we substitute t equals to 3 into the equation. So this shows by 2015, the value decreased to around 1,439. So next, for the past value, to find the value in 2011, we substitute t equals to negative 1 into the equation. So the value in 2011 was about 7,187. So that's all for me, and I will hand it over to our next presenter.
For the question number 1, are the values calculated from the particular solution accurate with the actual values? So for the question number 1 of analysis and discussion, are the values calculated from the particular solution accurate with the actual values? So we need to write down the actual value and measured value for the year 2015 and 2011, which is the future value and past value. And the actual value for 2015 was 1,473, while the measured value that we got from the calculation using the particular solution is 1,469. This shows a slight difference. However, in the year 2011, the actual value was 1,915, while the measured value that we got from the particular solution was 7,187. So, this shows that the values are not completely accurate because the values calculated from the particular solution have a small difference with the actual values. For the question number 2, find the percentage of error, if any. And as usual, we need to write down the measured value and actual value. And the future value, the t is 3. And so we calculate the percentage of error for the year 2015 using measured value minus actual value divided by actual value times 100%. So we got 2.31%. For past value, which is t equals to -1, and we use the same formula, and we got 273.50%. This shows a very big percentage of error for the year 2011.
The third question is, if there are any difference between the actual value and also the calculated one, what are the reasons? The first reason is human error. People do make mistakes, and so as researchers. Sometimes, because of the miscalculation, the incomplete data and also faulty method can lead to a wrong data research. And also, since Gemsbok are very rare, it's very hard for them to research and track them accurately. The fourth question is, what has affected the population growth in the past? Mainly because of the habitat loss and hunting. Sometimes, Gemsbok habitat are used for farming and also livestock. Plus, poaching and more predators have made it harder for their population to grow. And the last question is, what do you think might affect the population in the future? Personally, I think it is because of the climate changes. Even though Gemsbok can survive dry and hot weather, their food can't. And since they are herbivore, it is very hard for them to survive with a limited food.
So, in conclusion, by applying the particular solution that we got from the differential equations, we were able to estimate both future and past populations values of the Gemsbok. And as you can see, the prediction for 2015 was fairly close to the actual data, with a small error of 2.31%. And this shows that the model is accurate for the future values. However, the prediction for 2011 showed a large error of 275.30%. This shows that the differences between predicted and actual values may be due to human errors such as calculation mistakes or wrong methods. And one other causes of the differences is environmental changes that the model cannot be accounted for, such as natural disasters and ecosystem shifts. So, that is all from us. Thank you for listening.
So today I'll be presenting task 2, which is Newton-Raphson. So, Newton-Raphson is a numerical method to solve f(x) equals to 0 equation. This method uses tangent to search for a root. It can only be used to solve single variable and non-linear equation. This is the formula of Newton-Raphson. So, we were given an equation which is e power of x cubed plus ln 2 power of 2 equals to -2 in the bracket x minus 2. Using Newton-Raphson method, we need to find the root of f(x) equals to 0 by taking x between 0 and 1. Then, state the answer correct to 6 decimal places. So, using Excel, we need to rearrange the equation into f(x) equals to e power of x cubed plus ln 2 power of 2 plus 2 in the bracket x minus 2. Then, insert the equation using formula in the Excel. After that, we need to find the derivative of equation f(x) and reinsert the equation using formula in Excel as shown. Following the equation, we need to use x between 0 and 1. So I chose x equals to 0.10 as initial x, x0. After that, we need to insert the x 0.1 into f(x) equation and derivative of f(x). To find x1, we need to insert the value of fx and derivative of fx into the Newton-Raphson equation. Using Excel, this is how the equation looks like in the Excel. We need to repeat until we get the exact root value like this. This is the data obtained for this equation. First of all, I use initial x as 0.10. Then we got the fx equation, and then insert into the derivative of fx, we got 2.03 here. And then in the x column, we're gonna use the Newton-Raphson equation, insert it here, and we get the final value is 0.845222. And this is the graph of the function. As you can see, the function is an exponential function, and here is the graph of exponential. This is the closer look on the graph to find the root. You can see here, it is near to 0.85. That's all from me. Thank you.